Okay, here we go. So all of the graphs that we're going to be looking at today, that we're going to be graphing today, are going to be of this form: y equals a over x minus h plus k. They're all related to the parent graph. And so if we know what the parent graph is, can anybody tell me what you're going to be doing to that parent graph to get your new graph based on what you see here and what you already know from things we've done earlier this year? Sarah? Okay, you can think of it as expanding by a factor of a, moving to the right h and up k. The whole thing about a, though, I'm going to take care of that in your parent graph because I think it's just as easy to do it that way than to do the whole expansion, but you're absolutely right, okay? So start with the parent graph. And the parent function for this is, I'm just going to say it's going to be y is equal to whatever your a value is over x. Bless you. And it should be pretty easy to get some key points on this graph. Some key points. Remember, do you remember from yesterday how we graphed this? When we graphed, I think we did I do 8 to the x power, or I'm sorry, 8 over x? I think I sketched a real quick graph. And we saw that this graph had what? What was kind of special about it? And a little bit different than the other graphs that we've looked at so far. Okay, there were 2 branches, and they didn't touch either axis, right? They had 2 asymptotes. So some quick points here would be, if you replace x with 1, you're going to get a. If you replace x with a, you're going to get 1. There are 2 quick points for that first branch. And what are some quick points for the other branch? Okay, instead of putting in 1, put in -1, and we'd have negative a, and put in negative a, and we would have -1, and that would get us the other branch. Okay? So, branch. These are actually the 2 pieces that we're talking about, right? There are 2 pieces. And the one that we saw yesterday, we had a piece in quadrant 1 and a piece in quadrant 3. 1 branch in each of those 2 quadrants. Any ideas what else could possibly happen to that? If there maybe were a negative in front of that A? What about your branches then? Matt, what were you thinking? Okay, so instead of being in quadrants 1 and 3, it might be in quadrants 2 and 4. Okay, so that's a possibility too. Okay, now if you think about this, what about the domain of this graph? That means what x values can work. So if you think about what it looked like, right, and we said from yesterday it looks something like this, where you have these 2 asymptotes. It'll be something like that. What about the domain? What about the x's? Can x be every number? It can't equal 0. And there are 2 ways you can tell. Number 1, it never gets to 0 on the graph. But number 2, the equation, look where the x is. It's in the denominator. And do you remember what we've said about an x in the denominator? Yeah, it can't be 0. We can't have a 0 in the denominator of a fraction. So the domain is going to start out to be all reals. X cannot equal 0. Okay, what about the range? That's the y values. Look, how far down does it go? Forever? How far up? Forever. Does it hit everything in between negative forever and positive forever, or negative infinity to positive infinity? It doesn't hit 0, right? Because you have another asymptote. So the range is, whoops, all real numbers. Y cannot equal 0. It's the other asymptote, right? Which really helps you with your asymptotes, because you've already told me the 2 asymptotes were the 2 axes, weren't they? So one of them is x equals 0. That's the vertical one, the y-axis. And the other one is y equals 0, which is the horizontal one. Okay? Now, all we're essentially going to be doing is taking these graphs and moving them, like you said, left, right, up, down, however, whatever it happens to be based on the parent graph. So Any questions on those things to begin with? So let's look at this. If we had this graph, y equals 6 over x, I would just consider this the parent graph right from the beginning. Because you should be able to pick probably 3 or 4 points in each branch pretty easily. Can you? What are some easy key points here? 1, 6. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. 6, 1, 2, 3, 3, 2. And that's probably good. I mean, you already know the basic shape, don't you? Because we've already talked about it. So, here is one of your branches. What about the other branch? Yeah, just the negative. So, negative 6, negative 1, negative 3, negative 2, negative 2, negative 3, and negative 1, negative 6. Okay, so there it is. So it says to graph, but then it also says to describe the properties. So what are some properties of this graph? Tell me some things about it. Go ahead. What are they? Okay, it has 2 asymptotes, right? And they are x equals 0 and y equals 0. Okay, what else? Okay, the domain is all reals. X cannot equal 0. Hello, were you going to say something? Okay. Yeah. There are 2 branches, right? There are 2 branches, just like before. Shouldn't surprise you. Okay, something we haven't talked about yet are, oh, go ahead. Yeah. Yeah. So if you have the point a comma b, then you also have the point negative a comma negative b, right? And here's why. The reason that that's true has a little bit to do with the other thing that I want to point out to you. There's something else special about this graph. And we talked about it, oh gosh, we talked about these things with parabolas. They all have, yeah, they all have a line of symmetry, don't they? Where is the line of symmetry? X equals 1. X equals y, so something that goes up here like this. Okay, so I could draw that dotted line from corner up here to corner. Is that a line of symmetry? Is that what everybody was thinking for a line of symmetry? Taylor? Yeah, couldn't it also be the other one? Y equals negative x? Couldn't I also reflect over this line when those 2 branches land on top of each other again? Yeah? So it has 2 lines of symmetry, y equals x and y equals negative x. So we can put that down here too. 2 lines of symmetry, y equals x and y equals negative x. Any questions on any of that? Okay, well then let's look at this one. How is this one going to be different? Y equals negative 3 over x. What do you think? What's going to be different? Matt? What are you going to say? Yeah, it's going to be in the other 2 quadrants. But if you just use this as your parent graph, I think you can get your points pretty easily. Because if you just start out by putting in 1, like you did before, you're going to get negative 3, 1, 2, 3. And if you put in 3, you're going to get negative 1. And those are probably the best points, right? There aren't really any other nice points, but you should know the shape. So those 2 points should help you determine the graph, doesn't it? Don't they? Okay. So go ahead and draw that branch. And then where do you get your other 2 points? Yeah, just the opposite. So if I put in -1, I'm going to have 3. And if I put in -3, I'm going to have 1. And here's this branch. How do the properties of this graph compare to the properties of the last one? John? They're the same, aren't they? Nothing changes. They have the same lines of symmetry. They have the same domain. They have the same range, right? Everything is the same on there. Any questions on how to graph those? Okay, then let's do this one. Y equals 1 over x minus 2 plus 3. Where are you going to start, Ella? Yeah, just graph 1 over x to begin with. Now, on that one, if you were going to graph 1 over x, what are some nice points in that one? 1. If you put in 1 for x, you get 1 for y. Everything else is going to result in a fraction, isn't it? You could probably do 1/2 pretty easily and do 1/2 comma 2 and 2 comma 1/2. Okay? But other than that, all the other points are going to be fractions. And can you see your other branch that's going to be over here? Okay? Now, that's not the final graph in this case. What do you need to do with this graph? Right 2 and up 3, right? Now, how many asymptotes are in this graph? 2. Are they going to move as well? Yes. So I would move them first. It makes it a lot easier. So if you take this one and you move it to the right 2, does it move? No, but if you move it up 3, do you see that it's going to move up 3? Okay. Thanks. All right. And then the other one, thank you. The other one is going to move how? Just to the right 2, isn't it? So come over here and put your other asymptote here. And now you can just move that whole graph. Now, I wonder, is this going to let me do this? Yes. What I sometimes do is, if you get your asymptotes placed in the right spot, then this, if you use this as your new, I guess, origin, you really can just graph 1 over x right from here. Use those same points. Okay, so 1, 1 was a point, over 1/2 up 2, over 2 up 1/2. If you would rather do it like that, instead of counting to the right 2 and up 3, you can. Do you see what I just did? I just transferred my my origin right to there. And then I know the same thing is going to happen over here. And that way I don't really have to count all those spots. And I might not even need to draw the parent graph. Does that make sense? Just do your parent graph right from where your new asymptotes are. Okay, well, what about your properties on this one? Mm-hmm. Y equals what? 3, good. And x equals 2. If you know the asymptotes, what else do you know? Domain and range, because these are the things that it can't equal. So the domain is all reals except for can't equal 2, and the range is all reals except for 3. Okay? Here's kind of a tough one. What about the axis of symmetry? Are they still those lines y equals x and y equals negative x? No. Gets a lot trickier here, doesn't it? They're easy to draw. Once you get them drawn, you might be able to get their equation, because why is it easy to draw? Where do they have to go through? Yeah, that new origin, so to speak, right, which is the point 2 comma 3. Doesn't have to go through the point 2, 3. And what has to be true about the slope of each of those? It still has to be 1, right? So let's see. It would have to go something like this. There would be that one, and corner. There's 1. Do you see the other one? You could probably get the equation because you know the slope is 1, and if you follow this through, you see the y-intercept is 1. So its equation would be y is equal to x plus 1. And then you could probably do the same thing with the other one, right? It's going to go up like this. So it's going to end up being, since it's going downhill, its slope is, yeah, whatever that number is. 1, 2, 3, 4, 5. So y is equal to negative x plus 5. You see how you could get those? It's not too hard. Pardon me? Because the slope is negative because it's going downhill, right? So it's a negative 1. Yes? That's just the parent graph, and it comes from whatever the numerator is over just x. It doesn't matter what's down here. So it's just the numerator value over x. Okay? Does that make sense? All right. Then let's just take a look at one more and see if we could do this one. So y equals negative 2 over x plus 3 plus 1. So let's just get the new asymptotes and use that as our new origin point and go from there. Ella? So how are we going to move these things? We do move it to the left. How many? Okay, left 3 and up 1. So move your asymptotes. So move the vertical 1 to the left 3. 1, 2, 3. And move the horizontal 1 up 1. Now, using that intersection point kind of as your new origin, what graph should we be drawing? We should be drawing y equals negative 2 over x. So if you put 1 in, you're going to get out negative 2. And if you put 2 in, you get out negative 1. Do you see how I'm just doing that right from that point? And then, yeah. This way I don't even around. And then if you put in negative 1, you're going to get out a positive 2. And if you put in a negative 2, you get out a positive 1. So I'm just using this intersection point as my new origin, right? Because I'm not really plugging in negative 1 and negative 2, right? But in relationship to this, I am. Does that make sense? Could you give me the domain and the range here? The domain is all real numbers. X cannot equal good. And the range, all real numbers. Y cannot equal 1. So then you also have your asymptotes, right? Okay. All right. Any questions on how to graph these? Okay. Then one other quick example. Write an equation for the translation of the graph y equals negative 1 over x that is 4 units to the left and 5 units up. So I want you to take this parent graph and rewrite it so it's going to move 4 units left and 5 units up. Raise your hand when you think you know it. Yes. Okay, Natalie, what do you think? What do you guys think? Yeah, that's it. Okay? That's all there is to it. All right. Let me put your assignment up here. Oh, there's extra credit. I forgot. Here it is.